Hello, math students, and welcome to the first lesson in our second unit in Algebra 1. This unit is probably one of the most important units we'll do. It's the linear function unit. So some of your prior studies may have included some linear function work, but because you could be rusty, or you may have forgotten some of those things, this first lesson is just going to be kind of a review, kind of wake your brain up to some of the topics you may have looked at before. So this first packet that you've been given, Unit 2, Linear Functions and Graphs, Introduction to Lines, and the relationship between X and Y, starts off with these two questions. And hopefully by now, maybe you've even answered them. Number 1 says, think of a relationship you have with someone and write down his or her name. It could be mom, dad, grandma, etc. So I wrote down Joe. Joe is my fiance, so I'm definitely in a relationship with Joe. Number 2, does the behavior of the person named above affect you? I put caps lock yes with an exclamation point. Joe's behavior certainly does affect me. When he's in a good mood, it affects me in a positive way. If he's having a bad day, it may make me feel bad and affect me that way. But definitely our human relationships, whoever we're in them with, has an effect on us. So what I wrote below this is, math is much like human relationships we have. Weird, right? But it's true. Today we will examine the relationship between X and Y and piece together how this relationship sometimes, I'm going to highlight that word, sometimes. In this chapter it's going to happen all the time, but sometimes creates a pattern that eventually results in a line. So those are the kind of patterns we're going to study. When you get into higher level math courses, relationships between X and Y make all kinds of different shapes and graphs. But in this unit, our relationships will be making lines and we're going to examine why. So let's take a look at example 1. Examine the relationship between X and Y below. As X changes, write down how Y is affected. So as the behavior of X changes, this is like Joe, how's it going to affect me, Miss Callahan? So here's the relationship. The relationship that X and Y are in right now is given by Y is equal to twice X plus the constant 4. So this is the relationship that X and Y are currently engaging in. And we're going to see what happens to Y as the behavior of X fluctuates, as it changes, you know? X is going to get a little moody right now, so we're going to change the mood of X and see how it affects Y. Okay, so let's look at it here. It says, what happens to Y when X is -5? Okay, well, we know in math is means equals. So when X equals -5, what's Y? So I am just going to plug -5 right up in here for X. So this is going to give me Y equals 2 times -5 plus 4. And if I take 2 times -5, that's -10 plus 4 is -6. So that's the effect. So when X is -5, Y is -6. This is the X-Y relationship. Okay, what happens to Y when X is -4? Okay, so X equals -4. So then Y would equal twice -4 plus the constant 4. Here we have -8 plus 4 is -4. So when X is -4, it affects Y because Y changes to -4. Do you see? The effect on changing X affects Y. Okay, what happens to Y when X is -3? Equals -3. So Y will be equal to 2 times -3 plus 4. That's going to be -6 plus 4, which is -2. So we've got -3, -2. And this just continues down. So I'll just keep filling these in. When X is -2, 2 times -2 plus 4. Well, that's going to be 0. And you can even pause this video if you want to, fill these out for yourself, and then unpause it and check with me. Okay, when X is -1, Going to kind of speed through this now that you get the idea. That's going to be 2. So negative 1, 2. And then when x is 0, that's an easy one. 2 times 0 plus 4 is just going to give me 4. So 0, 4. Actually, I want to highlight this one. This is a special kind of point, 0, 4, and we'll talk about that in a minute when we plot these points. What happens to y when x is 1? Okay, 2 times 1 plus 4, that's going to be 6. So 1, 6. And finally, what happens to x when y is 8? Oh, hold up there. Did you catch that? They tricked me. It says, what happens to x when y is 8? They tried to catch me on not reading carefully, and they almost got me. So what we're really asking here is, what's the effect on x when y is 8? Interesting. So I got to be a little bit more clever here. So I have to go back to my relationship up here, and I have to let the y be 8. So this is going to look like 8 equals 2x plus 4. And so to solve this, we know how to do that. We subtract 4 from both sides of the equation to keep balance here. This gives us 4 equals 2x. And then we can divide by 2 on both sides to isolate x. So x equals 2. Aha. Okay, that one almost got me. Okay, now the next thing I want to do here, let's look at these ordered pairs. The effect of y when x change. So what I want to first examine are the x values. Take a look at the x values as you move downward here. How is x changing? -5, -4, -3, and so on. -2, -1, 0, 1, and 2. How is x changing? Well, if you need to pause it and think about it, that's great. Come back later. But what I'm hoping you realize here is that x is changing by 1. As I move down the table, I'm adding 1 plus 1, adding 1 plus 1, and so forth, and so forth, and so forth. So as I increase x by 1, let's take a look at how y changes. And again, if you need to pause the video to think about this, -6, -4, -2, 0, 2, 4, 6, 8. So hopefully you're realizing that y is changing by 2. You're adding 2 each time. Look at that, adding 2, adding 2, adding 2, and adding 2. So x is changing by 1, y is changing by 2, and this is consistent throughout. Okay, now when we turn the page, what we're going to do is now plot these relationships, plot the ordered pairs, that's these guys, the xy pairs, on this coordinate plane. So you may have to turn back a few times. The first point, if I remember correctly, was -5, -6. So if I'm plotting the point -5, -6, then I'm going to go, on the x, I'm going to go to -5, so 1, 2, 3, 4, 5. And on the y axis, I'm going to go to -6, 1, 2, 3, 4, 5, and 6. Okay, my next order pair was -4, -4. So I would go left on the x4, down on the y4. There we go. And I think my next point was -3, -2. And my next point was -2, 0. And my next point was -1, 2. And my next point was 0, 4. So 0, 4, when x is 0, you don't move anywhere on the x, stay put. 1, 2, 3, 4. And then I had my 1, 6. And then I had my 2, 8, which this graph only goes to 7 here on the y, so I'll just put it approximately where I think it is. Okay, so clearly we got something going on here when I connect these dots. And we've got some questions here underneath this. How do the points arrange themselves? Well, clearly these points arrange themselves in a line. Hope you noticed that. Here's the deal. Why do you think the points arrange themselves like this? And I'd really like you to pause this and give it some good thought before you listen to my answer. Why do you think the points arrange themselves like this? Like, why do they line up straight? Why not some circular pattern or some curvy pattern? Why are they perfectly straight? Okay, hopefully you paused that and thought about that. I'm going to actually flip back to something we wrote earlier. Every time x changes by 1, y changes by 2. Every time x changes by 1, y changes by 2. That is the relationship they're in. So let me kind of show this with a different color here. Let me start at this first point down here on the left. So every time x changes by 1 unit, y changes by 2. Every time x changes by 1, y changes by 2. X by 1, y by 2. 1, 2, 1, 2, 1, 2, 1, 2. And this will happen forever and ever and ever and ever. So it looks like if you change at the same rate, if your rate of change is the same, it's consistent throughout, then these points will always line up straight. So I'm going to write here, why do you think for every 1 unit, we move to the right on the x-axis, we move 2, typo, we move 2 units up on the y-axis. This rate of change is constant, so the points fall into a line. How does that sound? Just taking that off the top of my head. Let me reread that. For every 1 unit we move to the right on the x-axis, we move 2 units up on the y-axis. This rate of change is constant, so the points fall into a line. Okay, now the last little bullet here is asking us, how does the 4 in the equation affect the graph? So let me just recopy our relationship. Let's remember, our relationship was y equals 2 times x, and I think we've got that piece down. I think what we realized with this part of the relationship is that for every 1 on the x, y is affected by, it multiplies it by 2. So for every 1 on the x, we're multiplying that x by 2. So we're doubling it. So it's like a 1 for 2 special. But the plus 4, we haven't really addressed that yet. What about this plus 4, if you look back, that was hanging off the back end here? What's he doing? Well, you might remember from last year, or if you're seeing this for the first time, this back number, if you look at your graph up here, do you see how, I'm going to point an arrow here. Do you see how the green line crosses over the y-axis right here at 4, that is what this number is doing. And here's the reason why. This number will be itself whenever the x value is 0. So when you take 2 times 0, this goes away, and you're left with this back number. So y is 4 when x is 0. And what happens is, if your x is 0, and you go to the origin, you can't go right or left any because x is 0. You stay put right at the origin, and then you move on the y-axis to 4. So this guy on the back ends up being my y-intercept. Okay, my y-intercept. And we'll define y-intercept over here on the next page. But that's what that guy there is doing. So what that does is that gives us like a nice starting point. Say we don't want to write all these ordered pairs down. When we get later in the chapter into graphing, this is going to give us a nice place to start our line, and then we can do our 2 for every 1 relationship from there, which will get our points generated and our line graphed. Okay, last page here is just some key terms. We're gonna talk about these throughout the chapter, so we're just gonna define these right now, kind of based off the lesson we've just gone through. So I just talked about y-intercept. So let's write this definition down for y-intercept. Y-intercept is the location where a line crosses the y-axis. The location where a line crosses the y-axis. Key is the crosses the y-axis. Okay, the x-intercept then is like the same thing, but with the x-axis. So the x-intercept is the location where a line crosses the x-axis. Okay. The slope. Okay, the slope. We didn't talk about slope much. So let's turn back to and you may have heard of slope before. Let's turn back. When you think of slope like just the slope of an object, the slope of a hill, the slope of a mountain, the slope of a ramp, you've heard the word slope in your vocabulary before. And in math, slope pretty much means the same thing. Like, do you agree that this line right here has a certain steepness to it, a certain tilt, right? We can have lines that are this steep, we can have steeper lines, we can have less steep lines, right? Coming in that way can change the steepness. So slope can be informally referred to as sort of the steepness of a line, but really what creates that steepness is what we talked about right here in this lesson. It's really the rate of change. It's really the rate that you're changing on the y and the x that causes that steepness. So for now, because we're not doing a slope lesson yet, we're just sort of doing an intro here to our chapter, what I want you to write down for slope, informally, it's the steepness of the line, right? The tilt. But formally, slope is the rate of change of y with respect to x. It's the rate of change of y with respect to x. 2 for every 1, 2 for every 1, 2 for every 1. Okay, so guess what rate of change? Well, rate of change, let's put slope, okay, because we just defined slope as rate of change, so rate of change is slope. But again, it's how quickly y changes with respect to x. The rate of change, how quickly y changes with respect to x. 2 for every 1, 2 for every 1, 2 for every 1. Okay, now domain and range, we're going to get into way later in this chapter, but I thought I'd bring them up because you may have heard of them before. The domain of a function or an equation is the values of x. The values of x. And range, the values of y. And you might be thinking, well, the values of x where? Let's say the values of x on the graph of your line. And the values of y on the graph of your line. Okay, the values of x, the values of y. And we're going to talk about later in the chapter, we're going to talk about how when you have a line, a true line going infinitely far in both directions, your domain where your x is and your range where your y is, they're infinite. They run the whole gamut, all real numbers on the x and all real numbers on the y. So we'll talk about how to write that later in the chapter. And finally, function. You may have heard the word function before. And what we're going to get into with functions is you can write an equation, y equals 2x plus 4, this relationship between x and y. You can write it like this as an equation. But you can also use function notation. We'll get into that later. But function notation looks like this. The right side of your equation will be the same as the equation here. But instead of calling this side y, we call it function in terms of x, function of x, f of x. This is how we read this, f of x. So f of x equals 2x plus 4. These mean essentially the same thing. Now, the definition of a function is this. For every value of x on a graph, there is only one unique value of y. For every value of x on a graph, there is only one unique value of y. Seems pretty simple. It's like a one-to-one relationship. Well, we can see on our graph, we have that. This graph right here, if you asked me, is this a function? I would say yes, this is a function. And here's why. Every value of x, has one unique value of y. Like when x was -5, y was -6, period. There wasn't some other value it was. When x was -4, y was -4. That was it, one-to-one. And you can see that on the x-axis, for every value of x, there's just that one dot, one dot, one dot. If you can draw on your graph a vertical line down through an x value, like I just chose here -4, if you draw a line and it only strikes your graph one time, then you know you've got a one-to-one relationship and you have a function. But probably the easiest non-example of a function, like if I want to show you a graph that's not a function, one of the easiest ones I can draw you, say this is x and this is y, one of the easiest ones I can draw you is a circle. Clearly not a line, but if you have a circle, watch what happens. Say I go to x equals 2, right here. Well, little Mr. 2 on the x, not only does he have a value of y up here in the positive direction, he's got a value down here in the negative direction. So 2 has some positive y value and some negative y value. See how it's not a unique one-to-one relationship? 2's attention is being split between two different y values. So that's not a function. For this one, it looks like this value of x has 2 values of y. And again, if you draw that vertical line down through here, you see it strikes twice. So that's called the vertical line test. And if it strikes 2 or more times on a graph at any given value of x, it's not a function. So that was a lot. That was a lot of review. We're going to get into all of these concepts individually, one by one, but I want to kind of give you a broad sense of what we're going to start studying, which are these relationships between x and y that form lines. Thanks for watching.